Today I kind of want to finish this first subtopic. I think we can, okay, but just to give a short recap. So the topic that we're studying, the subtopic the subtopic we're studying is current, okay, and potential difference. But the thing is, we haven't even touched about current and potential difference. Yesterday, we were talking about an entirely different thing. We talked about the most important thing we need to know is what is an electric field. Okay, so in an electric field, it's a region where a charge experiences a force. And there are two types of forces. Okay, there are two types of electrical forces, okay, which are the repulsion force, okay, daya tolakan, okay, and the other one is the attraction force or the attractive force. Okay, so daya tarikan dan daya tolakan. So daya tolakan happens when you have same charges. Okay, manakala daya tarikan happens when you have different charge. Saya punya tulisan ni kan boleh jadi macam tulisan doktor punya tulisan saya. Okay, and then after that, we talked about electric field strength. Okay, we talked about electric field strength. And then the definition for electric field strength, you've already copied down from your textbook, I hope. Okay, but we are talking about two different cases. Okay, we're talking about 2 points. Okay, and then the other one is two parallel, okay, two parallel plates. Okay, two plates that are parallel. So in this one, the electrical field strength, I think is the letter E, okay, equals to the voltage over the distance between the two plates. And the color, this one is E equals to the force, okay, over the quantity of charge. And yesterday I mentioned that the quantity of charge, which is given by the letter Q, okay, the unit for the quantity of charge is this letter C, which is called coulomb. Okay, and this is something that we're going to be looking at today. Okay, and then after that, we ended by talking about what is so important about this electric field strength. Apa yang penting sangat pasal ini? And we looked at two situations. The first situation is the one with the ping pong ball. Okay, the ping pong ball. So the electric field, okay, is the one that causes it to go back and forth. Okay, because you know the charge keeps attracting one another. Okay, and then the second one is the situation where we talk about the candle in the electric field. Okay, when we put a candle in an electric field, we find that if let's say this is the negative side and this is the positive side, we find that the flame is bigger towards the negative. Okay, manakala towards the positive is a lot smaller. And this proves to us, okay, two important things. That number one, in the candle itself, there are both positive and negative charges. Okay, and secondly, that the positive charge is heavier. Okay, and that's why when the positive charge is attracted to the candle, when the positive charge is attracted to the plate on the negative side, okay, there is more weight on this side, okay, because the positive charge is bigger. All right, so let's continue. And unfortunately, I want to tell you this. The next part, most of the slides are in Malay because I haven't gotten the English part yet. So I will translate everything into English so that you can fill it in. So now let's really talk about electric current. Okay, so we are at our module in the 4 boxes over here. Okay, so electric current. Okay, this is electric current. Okay, dalam bahasa Melayu dia cakap peralatan elektrik akan dapat berfungsi sekiranya terdapat arus elektrik mengalir dalam litar elektrik yang lengkap. So an electrical appliance can fully function okay, if there is current flow. Okay, in a complete circuit. This is a very important thing. Okay, current must be able to flow in a complete circuit. Okay, when the circuit is complete, then current can flow and then your peralatan electric can function. Okay, so the definition for electric current, okay, is the rate of charge flow, okay, Q in a conductor. Okay, so this is the definition for electric current, which you can write in your box now lah. Okay, arrows or electric current, which is given by the letter I. Okay, I for current. Okay, is the rate of charge flow. Okay, Q. Okay, inside a conductor. And so we get the formula over here lah. Okay, the formula is I equals to Q over T. Because remember the word rate, asalkan dia ada rate makan, then it will always be over time. Okay, so the number of charge, okay, jumlah charge, okay, divide by the time will give you the current. Okay, and the SI unit for current is either coulomb per second or otherwise known as ampere. Okay, now as I said before in the beginning, please differentiate between electric current and voltage. They are two totally different things. Okay, so electric current, the symbol is I and the unit is ampere. Okay, A lah. Okay, so the formula is given over here, I equals to Q over T, and therefore because of that I can also use the same formula to calculate the value of Q. How much charge is flowing, okay, which is Q equals to I times T lah. Okay, all right, moving on. So what is electric current? Okay, electric current, okay, so this is an important thing. Now the direction of flow of conventional current is always from positive to negative, yang warna merah ini. Tetapi the electrons flow, okay, the electrons flow in the opposite direction. And this is a thing that we need to understand lah. Okay, electrons start from negative and they will flow towards the positive. But current flows from positive to negative. Okay, so this is the electron flow direction from negative to positive, and the traditional current direction is from positive to negative. Whenever we talk about current flow, okay, kita cakap pasal, okay, dia bergerak daripada terminal positif, okay, to terminal negative. But actually, what is happening is that the electrons are flowing from negative to positive. Okay, so arus mengalir sebab cas elektron mengalir. So there is a current flow because there is an electron flow. Okay, the only thing is that the current flow and the charge flow, which is the electron, okay, is opposite. Okay, and so the current flows from the positive terminal to negative terminal. Okay, actually I would like you to copy this down. Walaupun dia tidak ada, there is not really that much space there, but I need you to write this lah, or at least, you know, draw this out. Okay, just to remind us that current flow is always opposite to the electron flow. Electrons will always flow from negative to positive, but the current will flow from positive to negative. Okay, this is very important thing. So the electrons flow will cause lah, okay, arus mengalir sebab cas mengalir. Because the electrons are flowing, so the current will flow, but they are flowing in different directions. Okay, let me know when you finish copying. All right. Okay, so apa yang menyebabkan charge mengalir? Okay, what causes the charge to flow lah? Okay, so the current arus dapat mengalir dari satu titik ke titik yang lain because there exists a potential difference. So we say that current flows, okay, because of potential difference. Okay, current flows because of potential difference. Now, I want you to think of it in terms of like this. Let's say you're talking about waterfall lah. Okay, so biasanya waterfall kan dia akan mengalir dari tempat yang tinggi ke tempat yang rendah. You know what has changed? color of my water lah. Let's say the water is blue color lah. Okay, so the water will fall like this lah. Okay, water fall. So this is, yeah. And then in terms of potential energy, okay, if you think of it in terms of potential energy, okay, over here, because there is a certain height, okay, because there's a certain height, so over here you have potential energy which is high, manakala di bawah sini kan, dia adalah potential energy which is low. Okay, if you remember, the formula for potential energy is mass times gravity times height. The bigger your height, the bigger your potential energy. Okay, and that's why in a waterfall, the water must always fall, okay, from a place of high potential energy to low potential energy. Okay, and just like that, and because of that, this is the same idea as current flow. There exists a potential difference. Okay, ada wujudnya beza keupayaan, okay, between the 2 points. And since current is flowing this way, we always say that over here, the potential is higher, manakala here, the potential is lower. There is a potential difference. Okay, current flows because of the potential difference. And this is a singular most important thing for us to understand. Okay, potential difference yang saya akan cakap sebentar nanti, okay, is apa yang kita panggil sebagai voltage lah. Okay, tapi sebenarnya voltage itu merujuk kepada perbezaan keupayaan. Okay, perbezaan dia punya keupayaan di sini tinggi dan dia punya keupayaan di sini rendah. And because this is electricity, we're talking about the potential, the electrical energy potential lah. Okay, so because of that, this is beza keupayaan. This is potential difference. Okay, potential difference is the work done. Okay, W. Oh no, I'm using black color. Sorry. Potential difference is the work done. Okay, to move. Okay, untuk menggerakkan. Okay, 1 coulomb of charge. Okay, between 2 points, okay, in an electric field. Okay, so potential difference, okay, atau kita biasanya panggil ini sebagai voltage lah. Okay, tapi sebenarnya the actual terminology is called potential difference. So potential difference is how much work, how much energy you need to move 1 coulomb of charge, okay, between 2 points in an electric field. Okay, and that's why when we talk about voltage, we always refer to the voltage as energy lah. Okay, because dia sebenarnya adalah work. So the actual electrical energy, okay, which we're talking about is actually referring to the potential difference. Okay, and when there is energy, there is going to be current flow. Okay, just now we established that current flows because there is a potential difference. Okay, and the potential difference is the work done, how much energy you need to have, okay, to move 1 coulomb of charge between 2 points. Berapa banyak tenaga yang kamu perlukan untuk menggerakkan 1 coulomb charge antara 2 titik. Okay, of course, so let's say this is 1 coulomb of charge. Okay, so to move from this point to this point, you need less work lah. Okay, daripada if let's say my starting point is here, this is the charge, and I want it to go all the way over here to this part. Kalau begini, this one will need more potential difference. This one will have less potential difference because the distance that it is traveling is shorter. Manakala yang ini kan, yang besar ini, the distance is traveling is bigger. So you need a bigger voltage to travel through those 2 points lah. Okay, so voltage, as I repeat lah, okay, voltage is how much work you need to do to move 1 coulomb of charge, just 1 coulomb of charge, okay, between 2 points in an electric field. And so we find that the formula is V equals to W over Q, or energy lah. Okay, energy over the total charge flow. Okay, and that's why we can calculate the amount of energy, okay, or the amount of work, okay, which is Q times V. Okay, so the SI unit for voltage is joules per coulomb. Okay, because work or energy is joule, and then we know that the number of charge is coulomb. So it's either joules per coulomb or volt. All right, so let's do a couple of exercises now to get used to this. Okay, just to remind you, so we have I equals to Q over T, rate of charge flow. Okay, and the color V is equals to, I usually like to use E over Q. Okay, I know there's W over Q, but you can also use E over Q lah. Okay, if you want. Just to remind us, these are the two main formulas there. Okay, so question number one, state the meaning of a 15 amp current. Okay, so the meaning is there is 15 coulombs of charge flowing in 1 second. Okay, so 15 coulombs of charge, okay, flowing per second. Okay, because it's Q per T. Okay, so if it is 15 amp, means 1 second, there is 15 coulombs of charge flow. Okay, all right. Moving on, sorry, this next one is not. Okay, let's go to, this is question number 3. Question number 3, kan? Calculate the amount of electric charge. Okay, so the current flow is 0.5 amp. Okay, so you write this as letter I lah. Okay, now calculate the amount of electric charge that flows through the bulb in 2 hours. Now, the thing about this is this, so I equals to Q over T. This T has to be in seconds. Okay, you cannot count in hours. So they give you 2 hours, you have to change the 2 hours to seconds. And so this is how it will be. Okay, so Q equals to IT because I bring the T up. Okay, so Q equals to IT. So I is 0.5 amps. And then it's 2 hours times 60 times 60 to change from 2 hours to seconds. Okay, and so you will get 3,600 coulomb. For now, people just copy down the answers first. Okay, then later you calculate on your own. But if you want, you can just totally start off this one. Okay, now next question. If one electron carries a charge of 1.6 times 10 to the power negative 19 coulombs, find the number of electrons, okay, transferred through the bulb in 2 hours. Okay, so this one I actually didn't mention. So there's another formula, okay, which this is actually old syllabus but I think you should know also Okay, Q equals to N times E. Okay, di mana N, okay, N is the number of electrons. Okay, manakala E is the charge of one electron. Okay, Q equals to N times E, which is the number of electrons multiplied with the charge of one electron. Okay, so kalau saya mau cari the number of electrons, the charge is 1.6 times 10 to the power negative 19. Okay, so since it is 2 hours, so the Q we have already counted here, which is 3,600 coulomb. So 3,600 bahagi 1.6 dalam 10 kuasa negatif 19. So in 2 hours, this is the amount of electrons that are flowing. Okay, 2.25 times 10 to the power of 22 electrons. It's a lot of electrons, okay, to flow in 2 hours. No. Okay. Yeah, so this particular part actually this particular chapter has a lot of formulas. Okay, a lot of formulas and quite a lot of calculation. So it's important for us to differentiate between uh, the different formulas there are. Okay. Okay, can I move on?
Okay, sir.
All right. This is question number 4. Okay, this is question number 4, and I think this is question number 5. Okay, so electric charges flow at a light bulb at the rate of 20 coulomb every 50 seconds. What is the electric current shown on the ammeter? Okay, so the question is asking us to find the electric current. Formula is I equals, sorry, why am I even doing this? Okay, I equals to Q, okay, over T. And we can use 50 direct because dia memang 50 seconds saja. Okay, so it is 0.4 amps. Okay, this is number 4, this is number 5. Let me write it a bit nicer. I equals to Q over T. Okay, question number 5. Okay, when lightning strikes between two charged clouds, the electric current is 4 amps and the time is 0.05. Okay, so if we use the same formula again, okay, I equals to Q over T. Okay, I bring the T up, so IT equals to Q. Okay, I want to know how much is the quantity of charge. So 400 amps at 0.05 seconds is 20 coulombs of charge. Okay, quite simple, right? Just use this formula in this situation. The most important thing is that the time must be in seconds. As long as your time is in seconds, okay, then no problem. It's quite an easy formula to use. Okay, can I continue?
Okay.
Thank you. All right. This is, oh, this one sudah kena jawab. Sorry. Okay, this is question number 6. Okay, what is the meaning of 1 volt? Okay, so this is so a volt is a unit of electric potential. Okay, but this is what it means lah. Okay, 1 volt means 1 joule of work done. Okay, to move the charge, 1 coulomb of charge. Okay, between sorry, between okay 2 points. Okay, and this is the important one, in an electric field. Okay, so what is the meaning of 1 volt? 1 volt means 1 joule of energy, okay, or 1 joule of work okay, is needed. Needed. Oh no, my handwriting. Oh, okay. 1 joule of energy is needed to move, okay, to move 1 coulomb of charge between 2 points in an electric field. Okay, I repeat, 1 volt means, okay, 1 joule of energy or work. If you want to say work also can lah. Okay, 1 joule of energy is needed to move 1 coulomb of charge between 2 points in an electric field. Okay, 1 joule of energy is needed to move 1 coulomb of charge between 2 points in an electric field. One more time lah, since I already do 2 times, I must just do 3 times. 1 joule of energy is needed to move 1 coulomb of charge between 2 points in an electric field. So this is, if the distance if the potential difference or the voltage that you count is 1 volt, means between this point to this point is 1 joule of energy. Okay, so 2 volts means this point to this point is 2 joules of energy. Okay, but only for 1 coulomb of charge lah. Okay. Okay, just to sorry, so just to give you an idea how many electrons is 1 coulomb of charge. Now, if you remember from our formula just now, Q equals to N over, is it Q equals to N over E? Hold on, Q equals to NE, sorry. Q equals to N times E. So if let's say my charge, okay, is 1 coulomb, okay, and my E is 1.6 times 10 to the power of negative 19. Okay, can you calculate for me the N, please? 1 coulomb, and then E is 1.6 times 10 to the power of negative 19. What is the value of N? Sorry, you have to tell me because I don't have the answer over here. No, I do. How much is it?
6.25.
Times 10 to the power of
18.
Okay, times 10 to the power 18. So this means what, you know? Means in 1 coulomb of charge, okay, 1 coulomb of charge, there's 6.25 times 10 to the power of 18 electrons that are flowing. And this is what it means. Okay, dalam 1 coulomb charge, okay, ada 6.25 darab 10 kuasa 18. Can you imagine 18? 625 and 16 zeros at the back, you know. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. 1 coulomb of charge has this amount of electrons inside. Okay. And so between 2 points, if it is 1 volt, means you're using 1 joule of energy, okay, to make 625,000,000,000 electrons travel from here all the way to here. Okay. And that's quite amazing lah. We think about it. That means dalam 1 volt begitu banyak elektron sebenarnya yang mengalir. Okay, in 1 volt. That's how many electrons are flowing. Okay, so jangan kamu fikir yang elektron ni macam biji-biji yang bergerak. It's banyak biji. Okay, it's 6.25 times 10 to the power 18 electrons are flowing. And that's just 1 volt. Okay, remember yesterday when we were talking about extra high tension, we were talking about 5,000 volts. Okay, 10,000 volts, for example. Can you imagine how many electrons are flowing? Okay, kalau 1 volt saja, okay, is this amount of electrons. Bayangkan kalau 5,000. Okay, that's a lot of electrons that are flowing. Okay, let's continue. This is question number 7. Okay, question number 7. This is question number 8. And this is question number 9. I feel like I skipped a question. Okay, never mind. Let's do it. So, question number 7, if the charge of 5 coulombs, okay, and then you have the electrical energy is 2.5 joules. So, calculate the potential difference. Okay, so, oh no, why is it doing this bottom one first? Okay, never mind. So, V equals to E over Q lah. Okay, so since already given the voltage, given the apa ini, the Q is 5. Okay, the Q is 5, the energy is 2. Apa ini? 2. Oh, ini silap sudah ini. Sorry. Yeah, sorry. 2.5 divided by 5. Okay, so you get 0.5 joules per coulomb or 0.5 volts. Okay. Now, in this case, you're given a light bulb, okay, 5 coulomb of charge and 25 joules of energy. So we can calculate the Basel keupayaan. We can calculate the voltage by using the same formula. 25 divided by 5, which is 5 volts. Okay, so you see, the bigger the bigger the energy you need, okay, the bigger the voltage. The less energy you need, okay, then the less voltage you need lah. Walaupun dia punya bilangan elektron, bilangan charge adalah sama. Okay, the number of charges are the same. Okay, now this last one, I'm purposely showing you this one. Okay, so we know that V equals to E over Q. And at the same time, I also said that I equals to Q over T. So I can combine these two, okay, I can combine these two formulas by substituting the Q over here. Okay, and that's why you get V equals to E over I times T. Right? Because if I bring the T up here, this will be Q equals to IT. So I put the IT at the bottom here, E over IT, and therefore we get this formula. Okay, E equals to VIT. Okay, and this is something that we will also see a lot lah. Okay, but everything actually depends on what is the formula, what is the information given to you lah. You're given 20 volts, you're given 3 amps, and you're given the time, and you're asked to count how much work, how much energy. Okay, so we need to find the E lah. Okay, alternatively, alternatively, if you find that it's too difficult to do this, then what you do is you count the Q first. Okay, use the formula to count the Q. Okay, in this case, and then you put the Q inside. Okay, so if I were to do this, let me change color so it's easier for you to see. Okay, so if I were to do this, I equals to Q over T. So my I is 3 equals to Q over 50. So my Q equals to 150, okay, coulombs. Then I put the Q over here. So V equals to E over Q. My V is 20 volts. 20 equals to E over the Q I already calculated, which is 150. Okay, and that's where you get 3000 joules. So you don't actually have to memorize this, okay, but you need to know that these two are connected because both have the letter Q. Okay, both the formula for potential difference and current have the letter Q. Okay, so kita boleh saling bertukar-tukar, okay, inside the formula. Okay, so what I would like you all to do now is, can you answer the 6 objective questions first? Okay, try to answer the 6 objective questions. I know we don't have that much time, but what I will do is, yeah, okay. Why don't you try to answer the 6 objective questions first? I'll give you 10 minutes to do it, and then after that, we will discuss it. Okay, 6 objective questions. Number 1 until number 6. Yeah. Only number 2, 3, and 4 got calculation. Okay, so yeah, so can. So I give you about 10 minutes to do this. Okay, sorry, Adam number 1, Ava number 2. Who's number 3? Jacinta. Jacinta number 3. Michelle number 4. Shim number 5. And Wilson number 6. Did I say that correctly? Yeah, I think that's the one. Okay, Adam?
For number 1 is C.
C. Okay, good. Ava, number 2. Is Ava there? Hi, Ava. Are you here?
Yes.
Number 2, please.
I got D.
D. Okay, let's just double check. What am I doing? Sorry. Hold on. Oh, the answer is C. Yeah. Okay. Yeah. So this is the working. Okay. This is the one that we're using the 2 formulas. Q equals to IT, and then after that Q equals to N over E. I think so. Yeah. No. Sorry. Q equals to NE. Yeah. Okay. So the electron charge is 1.6 times 10 to the power of 19. Okay. All right. Moving on. Number 3 is who? Jacinta. Yeah, Jacinta macam.
Number 3 is D.
Did you say D or B?
D.
D. Okay, the answer is B. 2 times 60 times 60. Oh, there should be another 2, right? Yeah. Okay, sorry. The answer is D. Yeah, the answer is D. The answer is D. Okay, number 4, Michelle.
The answer is A.
A. Okay, good. So interesting that they put the answer for number 4, but they didn't put the answer for number 3. Okay, number 3 is 2 times 2 times 2, 60 times 60, yeah, because this is 2 hours. Okay, and then this is 2 amps. Okay. All right, number 5, Shim.
D.
Number 5 will be D. Okay, because the heavier side is positive. Okay, don't forget that the heavier side is positive. So here must be negative. Okay, because this is attraction force. All right. There's no number 6 over here. Okay, never mind. Number 6, Mr. Wong.
D.
Number 6 will be D. Okay, move continuously between P and Q. Okay, remember, if the question says that if you just turn on, but the ball is in the center, it will remain stationary. Okay, don't forget, the ball will remain stationary because it is being pulled by both forces at the same time and at the same force. Okay, all right.